Here we see some examples of diode models. In the first case, we have the diode that is forward biased, and it will have, being a real diode, some V sub F or forward voltage drop as the current goes from the positive anode to the negative cathode. We can graph this and show the current versus voltage curve, as you see right here, that as long as the diode is conducting in the forward direction, we will say that it has 0 voltage drop. This is the ideal diode right here. Meanwhile, if the voltage across the diode is backwards, or the diode is reversed biased, such that the anode is more negative than the cathode, we will have no current flow at all, regardless of the voltage. And that's what we're seeing on the horizontal line in the graph. Now, a real diode is going to have a forward voltage drop. So what we can do there is we can create a model using the ideal diode model right here, and then we can add the forward voltage drop in the form of a voltage source. So in this case, we now have a model which will allow us to have a forward voltage drop when the diode is forward biased, and we'll see that in that the vertical line is slightly displaced to the right, meaning that we do have a forward voltage drop. In reality, that can be 0.4 volts up to a couple volts. Now, if we want to actually have the reverse breakdown voltage shown, we can go ahead and show that in the case of a high reverse voltage or reverse bias, we again will end up with ideal diode together with a voltage source, and that is going to show that the diode will conduct in that case if we have a high reverse voltage. Typically, in the case of rectifier circuits and things like that, you never operate the diode there. There are other circuits where you do. The good news is you will not have to worry about it in this class. However, in a real diode, many times as the current increases, the voltage across the diode will increase also. So instead of just the straight V sub F, if we go to the next model, we will see that as the current increases, we may start with V sub F, but there's going to be kind of a positive slope here, which can be modeled by a resistor with our ideal diode and the forward voltage drop modeled by the voltage source. In this particular model, what we are seeing is we are assuming that there is no reverse current, or that the diode is perfectly an open circuit, if you will, when it is reverse biased. There are other models of the diode. Down on the knee portion right here, there can actually be a logarithmic function. We will not go into that. It is covered in the texts. But in this case, we can start with a simple model and say, all right, the diode is either on, which means we have forward conduction, or it is off, which means there is no conduction. So we can treat the diode as either an on or off device for many analysis purposes. And we will go there in a future video.